In today's video, we are going to talk about how the bearings or the angle of the elevation or angle of the depression are used in the real life situations. So it is required in the IB mathematics to know how to solve a problem by constructing labeled diagrams from the written statements. So label diagram from the written statement. So as a tip, it is always good to consider a diagram, and if you're stuck finding the size of the any angle or side lengths possible is always good place to start. Okay, so let's do example number 4 together. So we have two yachts, they're Taki and Stoki, and Taki notices a lighthouse 2.4 kilometers away on the bearing of 223 degrees. The captain of the Stoki measures the lighthouse as 2.1 kilometers away, and he also observes the Taki to the right of the lighthouse with an angle of the 53 degrees between them. We can say there's a Stoki, and Taki is more like in front of this Stoki yacht, and the lighthouse is more of between them. Okay, so but I place the Taki to the right of the lighthouse, so we can have the angle of the 53 degree between them, and the both yachts are facing the true north. Okay, so they are more of the linear, and we know that between the lighthouse and Taki, the length is the distance between the lighthouse and Taki is more of 2.4 kilometers, and the distance between the lighthouse and Stoki is more of 2.1 kilometers. And question A, we need to display this information on a diagram, so we already did. And question B, we need to find the distance between the yachts, so means we need to find this distance. Okay, we can use the cosine rule, but however it's quite complicated, so we're going to use a sine rule to solve this question. So we're going to do sine A over sine B over B. Okay, in order to do this question, we need to know the two sides and then one angle, or the two angles or one side. But when you look at this question, we know 53 degree and its corresponding side, but we just know the random two sides. So we need to figure out one of the angles to solve this question. So in order to solve this question, let's redraw this diagram. We know there's a Taki, Stoki, and then we have a lighthouse. And all three of them has true north is happening, right? So if I extend these true north lines like this, you can notice that there's a parallel diagram happening, right? That means since the bearing from the true north line to the line that is happening between the Taki and the lighthouse is 223 degrees, we can figure out this angle here, right? This angle is same as 360 minus 223 degrees, which is same as 137 degrees, right? Then this part is 43 degrees, and we just found the angle, right? The missing angle, 43 degrees. This is 43 degrees. That means this angle here is same as 84 degrees. We can say the angles 53 has the side 2.4, and then the angle 84 has the side, the x that we are trying to find. Then the x value is about 2.988, so it's approximately 2.99 kilometer. Okay, and question C. So we need to find this bearing of the Stoki from the Taki. So Taki's position is right here, and this is Taki's true north line. So let's redraw here. So this is Taki, and this is your true north. Okay, so we need to find the angle from here to here to find the bearing of the stocky from the techie. So since we know the angle here is 43 degrees already, we can say 223 degrees minus 43 is same as 180 degrees. Okay, so let's do example number 5. So we have a helicopter flies horizontally at 100 km per hour. An observer noticed that it takes 20 seconds for the helicopters to fly from directly overhead to being at an angle of the elevation for 60 degrees. So we need to find the height of the helicopter above the ground. So if we say this is the observer here, okay, we know the helicopter is happening here, okay, and it flies horizontally at 100 km per hour. So we know that there is some kind of a horizontal distance is happening, and there's angle of the elevation from the observer, and this is your ground, okay. And we know that the angle of the elevation is 60 degrees. So we have 60 degrees here. Okay. And we need to find the height of the helicopter above the ground. So we need to find this distance here. Okay. So this is what we need to find. Since we know that the helicopter is happening here, and it flies horizontally at 100 km per hour, and we know that it takes 20 seconds to fly from here to here, right? We can find the distance using the distance equals speed times time formula, okay? So distance for the helicopters to fly over the observer is 100 km per hour times 20 seconds times 1 hour, 3,600 seconds, because we need to convert the unit. Then we get about 0.555 kilometer. Okay, so this is the distance that flight or the helicopter flight over. Okay, now we need to find the height. That's what we need to find, right? The height. We know the distance. That means we need to know this distance here, right? So this is 0.555, and we know the angle 60 degree. Then since we know the adjacent value and the height is same as the opposite value, we can say tangent 60 is equals to opposite over adjacent, and is equal to height over 0.555. So the height is same as tangent 60 degree times 0.555. So this value, the height value, is about 0.963 kilometer, or is same as 963 meter.